Hi everybody, Chris here again from Core Electronics. I thought you'd like to see an IoT project done from start to finish, as fast as I can possibly do it. On the IoT device end, we're going to use a Pycom WiPy connected across the internet to Adafruit IO, which is an IoT cloud service. Don't worry if I run through things too fast. Below the video, you'll see the link to the documentation so you can do it at your own pace. So let's have a look at the hardware and see what we're using for this project. Here we have a Pycom WiPy. We're going to use that with the expansion board 2.0. We have a single connector so that we can put it into firmware upgrade mode and make sure the firmware is up to date. We have a micro USB cable connected to our Windows PC with wireless networking. Our access point here obviously has the internet on. And over here on the left, we have a battery and a phone so that at the end we can see the whole project working disconnected from any cables or computers. All right, the first thing we need to do is get our WiPy connected to the expansion board. With any of these devices, the LED end must be the USB end. That's the way to get them in the right way up. Okay, now if you're using anything other than a WiPy, make sure you've connected your external antenna at this point. Powering up the radio without an antenna will damage it. All right, so with the PC connected, we can see a little blue flash on the LED, and that's the heartbeat saying that the device is happy. All right, we'll move over now to the PC and we'll install the driver software. On the right here, you can see the Pycom documentation from docs.pycom.io. On this page, we have two links that we're interested in. The Windows link at the top gives us the Pycom Firmware Update app. And further down the page, we have a link in the procedure here called FTDI drivers. So that's the one we need. The FTDI driver is the one that gets the hardware installed. You can see on this page there's a large table with versions for everything. Okay, over on the device manager on the top left of the screen, we have an FT230X basic UART. That's our Pycom expansion board, and we need to install that. I'll just go back to my downloads folder and extract the zip file for the download. Okay, now we have the drivers unzipped. We can use them straight away. FT230X, update driver. Don't search automatically because Windows does that anyway and it's failed at this point. So browse my computer, go through the browse button, find the folder inside your downloads and use that. If you've got the right driver, it installs pretty much instantly. There we go, USB serial converter, and we'll close that. Now Windows has sorted that device into the USB controllers group. If we go back to the other devices area, we find a USB serial port is detected and not yet installed. So we'll do the same again, right click, update driver, follow the bouncing ball, and now we have a USB serial port installed. Here we go. So the most important thing to notice there is that if it's installed correctly, it's listed under ports, and yours may have a different port number. Mine is COM4. Okay, now come back to the bench with me for a moment. I'm going to unplug the WiPy so that we can do a firmware upgrade. To put it in firmware upgrade mode, we need a jumper wire connected from ground across to the G23 pin. And when we reconnect the PC at the end of the USB cable, we find the heartbeat has gone, which is right because we want hardware upgrade mode. Okay, back onto the PC. Looking again at my downloads folder, there's the Pycom firmware update application. We'll run that one. Use all the defaults and install it just as it will. And at the end of the installer, it'll start the application. Now, I should mention here that the only real way to damage any embedded device is to start a firmware upgrade and disconnect it while it's upgrading. Please don't do that. That will probably destroy your device. But other than that, anything else that might go wrong through this process will just result in an error message saying that the firmware was not updated and you can try again. So the instructions say to close any software that might be using the WiPy. you need to do something different if you're going to upgrade one of the expansion boards, and press the reset button. So I'm doing that. That's the button next to the LED. Select the right serial port. COM4 matches the one that we just installed in the device manager. And there we go. The board will be identified, the right download will come down, and then it will be flashed onto the WiPy. While we wait for that to happen, let's have a look at Adafruit IO. Again, it's a free service. You can click the Getting Started for Free link at the top there, sign in with your name and an email address. There's no payment required. Because I've already done that, I'm going to go through the sign-on screen. And you'll be able to see in here that you have a menu system on the left. The documentation is excellent. Anything that you might need to do in there can come from the documentation. I will use just some of the basic features to do the demonstration today. But we'll leave Adafruit IO for a moment. We've done the firmware update on the board, and all right, we'll have a look at what happens after that. Okay, so firmware update is complete. The jumper is still in. The light is not flashing. So we need to remove the jumper and then hit the reset switch. And we should see the heartbeat start up again. I realize it's a little hard from there, but yes, the heartbeat is on. Everything's running fine. So now we can communicate directly with the WiPy over serial or over Wi-Fi using Telnet or FTP. So Telnet just looks like an MS-DOS window. It's just a black on white text box, but you can type Python code directly into that box and have it run on the device immediately. So you can have an interactive time with it straight away. If you've used Arduino or something like that, you'll know that you write code, you check that it hasn't got errors, you compile it, you upload it, and then it runs. Now, one of the wonderful things with the Pycom devices is that Python runs a line at a time. FTP is file transfer protocol, so if you want to take a copy of the files that are on this device, just connect to it with FTP, pull the files down. When you've developed a program that you want on multiple devices, you only need to FTP the files to it. So as long as you know how to use Telnet and FTP, they're pretty basic, you need nothing else to work on this. However, it would be much nicer to have an integrated development environment. We would like to have a prompt where we can type code a line at a time and have that run straight away. We'd also like a text editor and something that manages files and transfers of files between the devices. So we should use Atom IDE because it has a purpose-made plugin for the Pycom devices. So let's go to the PC and we'll install Atom IDE and have it customized to work on Pycom. You can see again in my downloads folder, there's Atom Setup. I'm just going to double click that. This needs no interaction at all. It installs by itself. Where I've got that from though, is if you go to github.com/atom/atom, you can find a link there under the Windows heading to all of the latest installer files. So for this current version, there's an installer file there at the bottom of the list for Atom Setup x64 for 64-bit Windows, and the Atom Setup there is for 32-bit Windows. Here we go. So Atom has started up already. Now, the most important thing we need to do with Atom is install the PyMaker package, which will have everything set up for us. So on the right menu here, we'll go down the list under Get to Know Atom to install a package. And the button below that, now Open Installer. And the package we want to search for is PyMaker, just M-A-K-R on the end. And when we search for that package, we should find it immediately, and then we can click the Install button. Now, I'm going to run Putty, which, as I mentioned, is a simple app that can talk Telnet. I'm going to connect it over serial to COM4 at 115/200 baud rate and hit Open. Now here we are, we have a Telnet connection. It does nothing until you press Enter. There you go. You have a triple greater than sign. This is the MicroPython prompt. So any code you write here executes immediately on the Python, on the WiPy, and the results come straight back. So if I say print WiPy rocks, that command goes down the serial port to the WiPy, and the result of that comes straight back up the cable. Now, all that I do in this prompt is in the same context. So I can say import Pycom. The Pycom library will let me deal with the hardware on the WiPy. So now I can talk to Pycom and say pycom.heartbeat false. Whoops, if I type correctly. There you go. I'm looking at the WiPy and the heartbeat has stopped. So I can say pycom.rgb LED and give it hexadecimal RGB value. So let's make it red. Whoops, red. And the LED is now red. Okay, so I can build a program up line by line, and all of that code is executed at the end of the line when I press enter. Of course, in Python, if I put a colon in, I'll create a block that's indented, and I'll have to finish that entire block before it executes. So if you've played with the commands here and you decide you want to reset, start again, press Control D, and it does a soft reboot for you, and it's forgotten whatever you were doing. Okay, we'll close that now, because we want to have a look at our IDE. Now here we have Atom again. It has this big black box at the bottom, which is just like the telnet session we were looking at. And if we were to click in it, it automatically wants to connect to 192.168.4.1, which is the default for all these Pycom devices. Now the only reason we can't connect at the moment is we haven't joined the right network. If we have a look at Wi-Fi here, there is a Wi-Fi access point called WiPy-WLAN-238C. I'm sure your device will have a slightly different, probably 4-character code on the end. But if I connect to that and use the password www.pycom.io, which is the default, no, I don't need to browse on that network. So when Windows has joined this access point, this IP address will work. So that just requires a second. Right, there we go. I jumped out of it just before it showed up. So there you go. It is connected. And now when we click into this bottom box, we have the same dialog with the device directly through the REPL prompt. Now, REPL is what Python calls REPL, which is read, evaluate, print, loop. So any code we type is executed and the results come back. So again, I can say print hi, and I get a hi. So just as we did before. Now, just a few more features of this is we have a whole lot of tabs up here open by default. So I might just close these off. The welcome tabs and the setting tabs and telemetry consent. Okay, so now in the top half we have a code file that hasn't been saved yet. This is our next code file that we can create. In between these two panels though, there's a set of buttons. There's an upload, a download, a run, a disconnect, and some settings. If we have a look again, oops, wrong one. If we have a look again in settings, global settings, we can see here that by default, we're going to connect to 192.168.4.1 to talk to the device. Now, just because in this project we want to work on the Wi-Fi, and I actually want the Wi-Fi to change its IP address, we might change this to COM4, and you'll need to change that to the correct COM number for your device. Now we're saying we want to talk over the serial port and not over the Wi-Fi. So if I disconnect, I can just click in this box to reconnect. It now says connecting on COM4. So that little wireless access point that we joined, we don't need that anymore. We can go and tell Windows to forget about that. All right, we're disconnected. Now, let me talk about the cloud service we're connecting to and what we need to do about it. All right, so we have our WiPy device. It needs to connect to something on the internet, and in this example, it will be Adafruit IO. And we need to have a communication protocol so that both ends agree to talk the same language. In this instance, the best thing to use is a protocol called MQTT. We won't go through the details of how that works. However, it's designed to be a lightweight, fast protocol for small messages across the internet. So we're going to use MQTT. Unfortunately, I've had to pre-cook my code so that you can see so you can see the code that I've done, but you won't be able to see how I develop it. I've heavily documented the Adafruit IO Python file that I created, and the other file that we're going to use is UMQTT, which is really micro MQTT, and that will be taken straight from GitHub. All right, so let's go back to the IDE. Okay, now we have a brand new file here ready to go. However, it's important for us to download the files that are currently on the device. Before I download, I'm just going to create a folder for this. So from the File menu, I'm going to pick Open Folder. I might just plop it on the desktop and call it Adafruit IO, and open that folder. There we go. So now we have a file explorer as part of our project. So now when we hit the download button, we should be able to pull back the files that are currently on the WiPy. Now, whenever you reset your WiPy, it will create two files. There'll be a main.py and a boot.py. These are much like in Arduino, your setup function and your loop function, except that main.py doesn't loop automatically. If you have a look in these files, there's just a comment to tell you what to do. There's no actual code running in there yet. But if we wanted to make our WiPy run our application as soon as it's powered, we would put it in main.py. So we'll start with this blank text file. And as I said, I'm going to use some pre-cooked code. I hope my comments in here are comprehensive enough for you to understand. I'm going to paste this in and save the file. So Adafruit IO Pi. Now we get some nice formatting. You can see at the top, this is how the top of any Python file would look for MicroPython. You would import all the libraries that you need to run your application. In this example, I've broken out all of the settings that I need to use. So you can see the access point name and password that I use for Wi-Fi. Everything that's AIO underscore there is just Adafruit IO. We need a server name, we need a port number, our user, our AIO key, which is kind of an API key. We make up a random number to be our client ID, and we have two feeds. So we want to talk to the randoms feed and send it information, and we want to read from the lights feed and get settings from there. Now, if we were to run this now, we would have a problem. I press run, and the error I get is import error, no module named UMQTT. So all of those imports at the top are working fine except for UMQTT. So we need a new file for that one. I'll just do a Control N to make a new file. Again, I'll use my pre-cooked code. I'll jump over to the umqtt.py file, select all and copy, and paste this in. Now you can see at the top of this file that I've taken it directly from GitHub. It's called umqtt.simple. And I've tried a couple of these MQTT libraries, and this is the one that has worked best so far. So let's save that. We need to give it the correct name, umqtt.py. Oh dear, umqtt.py. A little dyslexia going on there. Now, if I went back to my Adafruit IO.py file and ran it now, I have the same error. Because although Adafruit IO.py is sent directly to the device when I click run, the other files are not. So umqtt.py isn't yet on the device. So if we now do an upload, sometimes this fails the first time and I reset the device and it succeeds the second time. There we go. So now 4 files have gone to the device. Obviously boot.py and main.py still do nothing. All right. Now if we were to run this file, we should see, aha, on the device we have a red LED. The device is connected to Wi-Fi and it's publishing. Now, if we go to Adafruit IO, let me just stop this running code at the moment. I just did a Control C there. Okay, if we go to Adafruit IO, we need to create the feeds that are the other end of the communications pathway from the WiPy to Adafruit IO. Now again, this is all in documentation, so it's pretty easy for you to follow along. Look at that, I didn't realize it created the feeds automatically. So the randoms feed was created for me because I posted data to it. I didn't know that was a feature. We need another feed, which I'm just going to call lights. And this feed will be command from the Adafruit IO end that will be actioned by the WiPy. Right. We need to create a dashboard where we can put some controls on. So we'll create a dashboard here. And I don't know, let's just call it Dash. When we go at the bottom of the screen into Dash, we can add a new block to the dashboard. There's a toggle switch, which would be great for turning on and off the LED. Let's use a toggle switch. So when we toggle the switch, which data feed are we connecting it to? That will be our lights feed. We'll click Next Step. Now we don't really need to do anything with the defaults here. When the toggle switch reads on, the value on will be sent out of the data feed. When the toggle switch reads off, the value off will be sent out of the data feed. So we'll create that block. While we're still in this dashboard, we will go ahead and create another new block with the blue button. Now this time we want to create a chart that displays the random numbers coming in from the WiPy. So on the right hand side there, I'm going to select line chart, and we'll link that to the randoms feed for its data source. And clicking Next Step. The defaults for the chart are fine. We'll just use them as they are, and I'll click Create Block. Now we have a dashboard that has a toggle switch to control the lights on the WiPy and a chart of the random numbers that the WiPy is sending every 5 seconds. For some reason, we just need to refresh the page to get that chart to operate. So I've just hit refresh at the top of my browser, and the randoms chart should now start plotting some data. There we go. Now Adafruit have done a wonderful job on Adafruit IO. If you bookmark this page on a phone, on a tablet, anything, it will work just as it does here on a PC. So you really can control this device from anywhere via whatever is convenient to you. We can also see the entire data set that has come through from the randoms feed. If I go back to the top of the page and select Core Chris, which is my user account, I can then run down the page. Oh, sorry, don't run down the page. From the top, select Feeds, and then I can run down the page. I'm going to pick the randoms feed at the bottom of the page. Now, you need to go down a fair way, but you'll see in there a line chart that displays all of the data in this feed, not just what's happened in the latest session since you opened your web page. And below the chart is an event list of what value was submitted at exactly what date and time. So it's really a wonderful system. It's a great place to start, and you can do some really good IoT projects using just this basic feature set. What we would like to do is have this application run as soon as we start the board. Actually, I'll show you one thing first. If you come and have a look at the bench with me, I'm just going to change my dashboard back to the first dash we created, and the lights switch here, I will click to switch on and click to switch off. Oh, look at that, somehow I've made the dashboard come alive. Okay, if you look over the top with me, here's the WiPy, here's the multicolor LED, and as it's sending out a new random number every 5 seconds, I can switch the light switch at Adafruit IO anytime I like and change the value of that light. Fully on, fully off. So we have two data streams here, completely asynchronous. The randoms number will not be interfered with by the light switch and vice versa. All right, now we want to go fully disconnected with this project. So come back with me to the PC for one last time. If we take the code here that works in Adafruit IO.py, select it all, copy it, put it into main.py. Now, Pycom devices look for these two programs, and if they find them, they run them. So I've saved main.py with our main program code in it. If I now upload, I'll take all 4 of these files again and copy them back to the WiPy. Upload failed. I'm going to do a Control-C. That stops my REPL connection running its default program. I'm going to disconnect and reconnect. And this happens from time to time. The upload button is gone. So I'm just going to restart Atom. And I should land directly where I was. Don't worry about that. Main.py file. Now we're going to upload. There we go. 4 files going to the WiPy. That looks like a reboot has happened straight afterwards. I can't see that the upload actually occurred there. Uploading done. Okay, it realized that there was only one file that needed uploading. Okay, so the board has reset because we uploaded. Now let's come back to the bench and see what's happening here. The green light is on, saying that it's connected to Adafruit IO. If I disconnect that now, we're not using the PC at all. Let's put a battery on. So this is just an ordinary 3.7 volt LiPo cell. Red, not connected to anything. Should go orange for Wi-Fi, and then green for Adafruit IO. So if I now have a look at my screen again, I'm graphing random numbers again, and I realize you're still looking at the device. I'll turn the light on full white, and turn it off to black, and full white, and black. Now, wouldn't it be great if we could do that from another device? Let's go directly into my phone. I've got an old version of the page. I need to re-authenticate. Sign in. Now I should have an up-to-date list. Here we go. There's the dash. Hopefully my randoms graph will appear on there any second. There we go. There's the graph. Here's my light control. So as you can see, I'm graphing and controlling the light. Data is running both directions. We're completely disconnected, except that we're using Wi-Fi for the WiPy, and those two things are happening asynchronously. All right, so I hope you've enjoyed our quick demonstration of how to build an Internet of Things device with the WiPy and Adafruit IO. Again, check the description down below for the documentation, and otherwise hit us up on the forums. Thank you for watching coreelectronics.com.au.